about. We're now going to do some exponents and logarithms. Okay, so taking a look at your notes. So an exponential function is anything that's like y equals a to the x. This base has to be greater than 0. It's not allowed to be 1. So let's look at a couple of these. Like let's say we have y equals 2 to the x, or y equals 3 to the x, or y equals 4 to the x. We're going to be talking about something called key points. Okay? Key points, one of them is if I plug in 0 for x, what would I get? What's 2 to the 0, 3 to the 0, 4 to the 0? It's 1, right? So 0, 1 is going to be a key point always. Every single exponential function that hasn't been shifted in some way, left, right, up, or down, is going to have a key point of 0, 1. Now, what if I plug in 1 into this? What's 2 to the first? What's 3 to the first? So if I plug in 1 for x, I get 1, 2 here. Here I get 1, 3. Here I would get 1, 4. So that's where this comes from, this whole concept that our key points are going to be 0, 1, and 1 base. 0, 1, 1 base. Now, talking about the inverse of an exponential function. The inverse of an exponential function is a logarithm function, and here is why. If I want to know an inverse, I change y to x, and I change x to y. Then I can rewrite this, because this doesn't really mean anything. X equals a to the y doesn't mean much. But I can switch this around to a log. The way that I do this is it's log, find the base, swirl it around. So right here. So this is, right here, this is the inverse of an exponential function, is a log function. Inverses, x turns into y turns into x. So the key points on this are going to have to be, instead of 0, 1, they're 1, 0. Instead of 1 base, it's base 1. Okay? Very important right there. For logs, these are the key points. 1, 0, base 1. For exponentials, there are the key points. All right, so let's just graph a couple of basic functions here. So if I'm graphing y equals 2 to the x, my key points are 0, 1, and what else?
1, 2.
Yes. So we're going to plot these, 0, 1, 1, 2. An exponential function is going to look like this. It's exponential growth. The way that I know that is because if I had 2, if I plug in 2 for x, 2 squared is 4. 3, 2 to the third is 8. See how quickly that's going to grow. Exponential growth grows very quickly. The equation of the asymptote, this is going to be our asymptote. We will never go below y equals 0. Our domain is negative infinity to infinity. Our range is from 0 to infinity. We only have one intercept right there at 0, 1. It's never going to cross the x-axis. To graph this log function, my key points are going to be 1, 0, base 1. I'm going to plot those points, 1, 0, base 1. Perhaps you don't know what that looks like, the log function. Well, you can use your calculator to help you. If you go to y equals, you can go under math. You can go down to log base, which is letter A. And now I can do log base 2 of x. I do a zoom 6. And here's the way the log function looks. Okay? So what the log function does is it gets infinitely closer to this. So see how in this one, the asymptote is y equals 0, but what's the asymptote here? X equals 0. Y turns into x. Should make sense. The domain here, the x's we can use, we don't start until 0, so the domain is 0 to infinity. The range, this is negative infinity, and then it keeps going up, 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 very gradual. So notice how the domain is the same as the range, and the range is the same as the domain. And that's because x becomes y becomes x. Anytime we have inverse functions, it's simply a reflection over the line y equals x. So you can visualize that. If I reflected that over, it would turn into this. We only have one intercept. It's 1, 0. All right, talking about shifts and reflections. If we have a negative in front of the x, this is going to be a reflection of the y-axis. If we have a reflection of the x-axis, that's going to be when we have a negative out in front. Do you remember what it means if we have x plus m? What kind of shift that is? It's not up and down, it's with the x, so it's actually going to be to the left. This is going to be to the left m. So therefore, this is with the x. This is going to be to the right m. When it's down here, not with the x, that's when it's going to shift it up and down. So this is going to be up n, down n. A negative out in front of the x here. This is going to be a reflection over, and it's the opposite. See how when it's a negative in front of the x, it's over the y-axis? So here's a negative in front of the x, it's a reflect over the y-axis again. This would also be going to the right m, and it would go up in. For this one, this negative out in front, that's going to be a reflection over which axis? X-axis, good. This plus m is going to take us to the left m, and this plus n is going to take us up n. All right, let's flip over to the back now. Let's graph a few of these. Okay, so anytime we have a function like this, 4 to the x, normally our key points are 0, 1, 1 base. Okay? But now we're going to think of shifting. This is going to go left 3 and down 1. So I have to take this point of 0, 1 to the left 3 and down 1. Can you figure out what that would be? Left 3, down 1? Good. Negative 3, 0. I think somebody said that. Okay. Next one, I want to go to the left 3. If I do 1 minus 3, that takes me to negative 2. Down 1 means I'm going to subtract 1 from my y. So I'm going to be at negative 2, 3. Now, the other thing that's going to happen is we usually have an asymptote of y equals 0. But now that y equals 0 is going to be shifted to the left 3. Does that change it if I have a line y equals 0 and I shift it to the left? No. But if I take it down 1, it's going to be here now. So my new asymptote is at y equals negative 1. And here's the way it's going to look. The domain is negative infinity to infinity. My range is now starting at negative 1 to infinity. I have an intercept at negative 3, 0. How do I find the other intercept, the y-intercept? What do? Plug in 0 for x. So let's plug in 0 for x. If I plug in 0 for x, I have 0 plus 3, that's 3. 4 to the third is 64, minus 1 is 63. So I can see my picture is not great. I shouldn't have tried to make it cross that axis there. It should have kept going up more like this. It doesn't cross the axis until I get to 0, 63. But I won't take off for things like that. Questions so far? All right, let's do another one. So normally our key points are 0, 1, 1 base. But now we have to do all of these things. What kind of a reflection is this? This negative in front of the x. Y-axis. So I have to reflect 0, 1 over the y-axis. That doesn't change it at all. I have to take 1 1/2 over the y-axis. That's going to take me to negative 1 1/2. I also have to go to the right 2. So I'm going to do this one step at a time. To the right 2 would do this. And then the last thing I have to do is go up 3. So here are my final key points. 2, I'm going to go up 3, 2, 4. 1, I'm going to go up 3, and that's going to put me at 3.5. So there are my final key points. See how I just did that one at a time? So I'm going to go to that key point of 2, 4, and then 1, 3.5. Right about there. All right, so I'm thinking of my normal function. If I have 1/2 to the x, that's going to be a decay function. See, I know 1/2 to the x is actually going to be going down. It's going to go like this. Okay? But then it had to get reflected over the the y-axis. So now it's going to look like this. Then it got shifted to the right, and then it went up. So this is the way it's going to look then. Here's my new asymptote at 3. It's going to look like that. I did a lot of transformations there, so this is something I might want to check on the calculator just to be sure. And it shows me that this is the way it should look. Okay, so we have it right. You got to think a lot on these, like about all the reflections and everything. Okay, the equation of our asymptotes, y equals 3. Our domain is still negative infinity to infinity. Our range is from 3 to infinity. The only intercept I'm going to have is right here if I plug in 0 for x. I'm not going to have, when I plug in 0 for y, to worry about. If I plug in 0 for x, I'm going to get 0 minus 2 is negative 2 times a negative is a positive 2, so 1/2 squared plus 3, that's 1/4, that's 3 1/4. See what I'm doing? Just plugging in 0 for x. Okay, great. All right, any other questions on the first two? Okay, guys, so again, remember, 2 to the x is a growth function. 1/2 to the x would normally be a decay function, but because it got reflected over the y-axis, it ended up being a growth again. Okay, logarithms now. Normal key points are 1, 0, base 1. Got to know that quickly. Got to think of our shifts. We're going to go to the left 1, up 2. So I have to take this to the left 1. That puts me at 0, up 2. This point to the left 1, and up 2. So those are my key points. Okay, my asymptote on these is normally x equals 0, but I have to take it to the left 1 and up 2. What's that going to make it then? Good. X equals negative 1. Moving that up is not changing it, but moving it over did. So now my domain is negative 1 to infinity. I don't start until negative 1. My range is from negative infinity to infinity. Here's the way it's going to look. A little more difficult to find intercepts here. I'm going to plug in 0 for x. If I plug in 0 for x, 0 plus 1 is 1. So this would be how I would find it. All right, this is kind of tough. But what is log base 3 of 1? Do you guys remember logarithms? Log base 3 of 1? Log base 3 of 1 means this. It means 3 to what power equals 1. You just swirl it around. 3 to what power equals 1? What is it? 0. So this is just 0 plus 2. So when I plug in 0 for x, I get 2 for y. 0, 2 right there. See how I already knew it anyway? 0, 2. That was a waste of time, but okay. Plug in 0 for y now. So if I plug in 0 for y, I'm going to solve this for x. So now I'm going to subtract my 2 over. This is some tough math that you probably haven't done in a while. Get rid of that. And now I have to swirl this around again. So what's my base? 3. So I have to do 3, swirl it around to the negative 2, equals x plus 1. What is 3 to the negative 2? 1/9 equals x plus 1. So subtract 1, negative 8/9, 0. Maybe I don't feel good about that. Maybe I think it's something is wrong. Well, I can go to my math. I can go to my log base. Just watch, guys. 3, and then I put in my x plus 1. I go over and out of that, plus 2. I'm going to graph it, and then I want to know what is that intercept there. In other words, when y is 0, what is x? Here's how I can do that. I can put it in. Y is 0. Second trace, calculate that point of intersection. That's my first curve. That's my second curve. Enter. Tells me that it happens at negative 0.88888. Is that 8/9? Yes. Okay, I know I'm doing this kind of fast, but we're running short on time. All right, number 4. Okay, we know that our key points are always going to be 1, 0, base. What's the base of natural log? You have to think back. Anybody remember the base of natural log? E. Do you remember learning E? Yeah, you learned E. You've just forgotten about E. Yes, it is. It's an irrational number, 2.71, etc. All right, take my word for it. When you see natural log, your base is E. So 1, 0, base 1. Those are my normal key points. My key points now, though, I'm going to have to go what? I'm going to have to go to the left 2. I'm going to have to reflect over what? Over the y-axis, and we're going to have to go down 4. So we're going to have to do all of that. So if I go to the left 2, I'm going to do this one step at a time for you. Go to the left 2 puts me at negative 1, 0. That to the left 2 is e minus 2, 1. Reflect over the, that's not over the y-axis. Correct me on that, guys. Over the x-axis. Reflect over the x-axis is going to put us at negative 1, 0, e minus 2, negative 1. And then the last thing I have to do is go down 4. Good. Questions on that? Are you kind of grasping this even though it's a little quick? What questions do you have?
Yeah.
Okay, E is 2.7. It's up here. 2.7. All right, so the equation of our asymptote, guys. So it's normally, for natural logs and logs, it's x equals 0. But I have to take it to the left 2. So what's it going to be now? X equals negative 2. Great. Let's put it in there. Okay, so now I have to plot these points. Negative 1, negative 4. E is 2.7 minus 2 is 0.7. So I'm going to be at 0.7, negative 5. So all logs and natural logs normally look like that. But what happened to this one? It got reflected over x. So now instead of it looking like this, it's going to look like that. So it's going to have to go this way. There's what it should look like. I can check it on my calculator here in a minute. So my domain is going to go negative 2 to infinity. My range is going to go negative infinity to infinity. Intercepts, ugh. Let's see, we've got 2 of them actually. Well, okay, I'm going to show them pretty quickly. If you understand it, great. I'm not probably going to make you find these intercepts though. So I would plug in 0 for y. Watch what I do here. So I would now have to bring over my 4, divide by a negative, and now I have to rewrite this. So it's going to go e to the negative 4 equals x plus 2. See what I'm doing? Swirling it around. Here's my base. I have to do base to that value there, swirl it around. And so then one of my intercepts is e to the negative 4 minus 2 comma 0. Take that back. No, I don't. That's right. That's what x is. So there we go. To find my other one, my other intercept, I have to plug in 0 for x. So watch what happens here. If I plug in 0 for x, 0 plus 2 is just 2. So there's my other intercept. 0 comma, negative natural log of 2 minus 4. Those are very tough. That's more collegiate type material there.
I feel like I should get paid for that.
Me too, I'm the one who did it.
You are.
All right. True, I am, you're not, right? Okay, any other questions? All right, so you guys have your worksheet to do. Only 8 problems. Make sure you